Hi, can everybody hear me? Okay. So my name is Hari. I'm a developer advocate at Solace, and today I'll cover three parts. What is Solace, what we do, or what we do in the agentic space, what's the use case or the demo that I'm going to be showing, and how it works, and hopefully it inspires you to think a bit more about what it does, right? So Solace is, we have been around for 23 years now. We are based in Canada. We are a company that deals or that is an event-driven architecture platform, right? So for people who don't know, EDA or event-driven architecture is where applications can publish events, which are small changes in state, system, applications, whatever. And there are applications which consume these or subscribe to these events, and they just react to those events, right? So for people who are equating us with Kafka, we are not Kafka. We are very different from it. We have a lot of customers. So for example, Heineken, Shell, the Eurocontrol, FAA, a lot of airports, a lot of retail companies around the world. So we have a pretty large customer base. One thing that we started off doing a few years ago when AI started booming is thinking how can we apply our real-time and EDA practices to an agentic world, right? And what we did is we built out a platform, an agentic development platform called as a Solace Agent Mesh. It's pretty similar to almost all the other platforms in the market in the sense that you can create agents, you can create workflows, you have an orchestrator in there, which is backed by an LLM, which gets your inputs at your requests, parses it, understands what it does, and then delegates to sub-agents, blah, 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 right? It's A2A compatible as well, or A2A compliant as well. So how do we differ from everything else in the market is all the agent interactions, so agent to agent or orchestrator to agent or orchestrator to sub-orchestrator or whatever you want to think, all these interactions happen through the event broker, right? So an agent could publish an event saying, okay, an orchestrator could publish an event to a specific agent saying, I have this input, do this thing, and give me back a result. That the agent does it on its own and comes back with a new event which publishes back to the broker, and then it is subscribed by the orchestrator, and then it sort of collates all this information from the various agents that it is talking to, right? So what it means is you build agents which are completely decoupled from each other. You can remove agents, you can add in 10 new agents. You don't have to worry about inter-agent communication or number of connections between agents and stuff like that. What I did is I built a small demo for a use case called as request for quote, right? I think Christoph, he mentioned about how you can say, or you can send an email, or you can ask somebody, okay, I want 2 refrigerators, or I want to buy 3 refrigerators, and give me a quote for it, or give me the amount that it will take, right? So this is what a request for quote essentially is, where you simply say, I'm looking at these and these products. I'm a customer of your company, so give me pricing and tell me how much time it will take for shipping, when can it be available, and stuff like that, right? So the use case itself is quite large in larger enterprises, or quite complex in larger enterprises, because you have to work with different data systems. You could work with product information or a master data system. You could work with SAP or Salesforce for pricing, availability, stocking, availability to promise, and stuff like that. You have to work with a third-party logistics provider to understand how much time it would take from point A to point B, what would be the cost, and stuff like that. So what I did is I essentially added in multiple of these agents. So I have a PIM agent, which is a product information management agent. It's essentially a RAG agent which queries an underlying database. It could be an MCP to a separate or an API call to a PIM system as well. I have the main orchestrator, which is obviously the brains of the thing. I have a code planning agent, which is the sub-orchestrator or the sub-agent or the workflow, which kind of delegates tasks to different agents. I have so for my pricing and availability, I went to SAP because that's the largest used ERP in the world, to be honest. And they have their own agentic platform, of course. So I built an agent around that, which will talk to this. And that's the Joule or the RFQ agent. And I have a real-time shipping integration with a shipping provider of my choice. It's called as ShipStation. That's it, right? So what I did is I have this nice prompt which says, I'm from this company. I'm looking at these products over here, and I'm looking for these quantities. Send it to me at this destination address, and it says I have a delivery date of, in the future, somewhere around end of September, October. And it says validate some things, do these things, etc. Right? So what happens in the background is, as soon as I go here, right? I have a nice visualizer which you can use to, does it? Okay, where you can see what exactly is happening, right? So it comes to the orchestrator, it sends it to the sub-agent or the sub-orchestrator, and it starts delegating stuff to the different agents. So the PIM, the Joule agent. Now, it's a very expensive and time-consuming task, so I have a small mock around it, but the real one works as well. And it calls the shipping agent as well, but then the LLM says that, okay, for the shipping agent, I need stuff like the sourcing address, the size of the package and stuff like that. So it keeps that on hold, right? And in the meanwhile, it goes along, it gets information from the PIM, it gets information from the LLM, from the SAP agents and stuff like that. And it kind of collates it together for a proper response. Okay? And so it talks about things like, okay, where can I source this product from? Which is the best warehouse? What is the, how do you say it? The shipping cost? What is the product cost and stuff like that, right? Now, again, very common implementation, pretty much works in all the other agentic platforms as well. Again, how does it differ from the Solidus agent mesh is, these are the interactions between the orchestrator, the LLM, the sub-agents, etc., right? Now, if I can go and somehow toggle the same, it actually shows the events that are being published and subscribed by the orchestrator and the different agents in the background, right? So all of these agents, they are put on to different topics, and it's just published it to broadcast around the world or to everybody, and then it's how do you say, it's subscribed to by relevant consumers or relevant agents, and they act upon the tasks that have been delegated to them, right? Okay. So what does this do for you is it helps you kind of decouple your agents from each other. If you have 10 agents, right? For building a completely agentic platform, you would have to build somewhere around 450 connections between them. Right? 450? Yeah. N into n minus 1 by 2. That's the formula usually, right? If you grow in more agents, or if one of those agents kind of misbehaving, or it's going wild or stuff like that, it's very difficult. It has a big impact on the other agents in terms of usability, in customer experience, and stuff like those. The event-based decoupling and the interaction between the agents using events helps in reducing that and helps in bringing that into control. To be honest, this idea is unique, yes, but it can be implemented with pretty much any software, any broker in the background. You just have to implement it yourself. AWS is even implementing this using what is called as durable Lambda functions in their own Lambda landscape. So you can actually take this theory of agents communicating with each other using events or an event broker and implement it in a platform or a language of your choice, to be honest. Yeah.
main agent plan to interact with other agents, or is this a workflow that you have?
You can do it either way. So you can simply let the LLM decide on what agents have to be called by itself. Or in some use cases where you say, no, I can't allow the LLM to have its own non-deterministic behavior. I want some kind of a probabilistic determinism in there. You can use workflows as well. So you can have workflows which says, call the agents in this specific sequence. And you can even say that this agent should have this input, it should have this output. You can do validations and you can do all of that. Another question. So I'll just go in sequence. Sorry. Yeah, go on.
Is it fair to say that this is basically a safe open flaw? Or am I misunderstanding this?
No.
No? Okay.
I think you could say, I was reading the docs, so.
Okay.
I think you could say this is a way for multiple OpenClaw instances to even communicate.
Yeah. So ideally speaking, any agent that is A2A compliant, you could simply integrate into this platform. We have an A2A proxy, and we need that because your A2A agent, by definition, it works only on HTTP and SSEs, right? But we work on agents. So we need that proxy bridge in between to have the orchestrator or the Solus agent mesh platform interact with your non-Solus A2A compliant agent, or non-Solus agent mesh A2A compliant agents. That guy, I had this question answered. Thank you.
Yeah, so what I'm seeing here is from an email to a complete procurement offer, and this use case is logistics. But what's the biggest use case you have? Because I can imagine if I change the agent, I can apply to every industry.
Yeah. So again, the question was the agents to a procurement response, but this workflow can be applied to any other use case as well. Yeah, sure. So ideally speaking, you can have as many ways of interacting or triggering the orchestrator itself, right? So you could have a chat window, or you can have an event, or you can even have an email which is sent to the broker, or which is pushed on to the broker as an event. So you could do a variety of those things. A Slack, a Teams message, or whatever, right? So ultimately, all the orchestrator really needs or should need in an EDA-driven agentic solution is an agent to kind of go do your work. And it can be applied to any use case as well. Yeah, true. You had a question.
Yeah, again about the A2A part. How good is the support actually right now with these enterprise platforms for you to talk to their agent? Because I know they really like for them to be the orchestrator and talk to your agent.
Yeah.
But the other way around, is that support kind of good?
Yeah, sure. So the compatibility between the Solus agent mesh and the other enterprise platform agents which are A2A compliant in some way, right? So A2A compliance is not a given, to be honest. Even Google's own agents are not 100% A2A compliant.
Can you also explain what is A2A compliant?
Sure, just give me one second. Okay, so let's start with that. So A2A is, or agent-to-agent communication is a protocol that was released by Google in collaboration with pretty much everybody, every notable person or notable company in the world, right? And the idea behind it was that you have a standardized way of agents to kind of introduce themselves to the outside world, saying, okay, this is my name, this is my skills, these are the tools that I can use, and how can you reach me, right? So simple as that. Again, it's a protocol, and what it does say is how this communication should happen. Interestingly, it does not talk about the transport layer for this communication, and it just says HTTP and SSEs are the most common ones. That's all it says as a protocol level. So we just took this whole protocol and we made it compliant. We made it work with agents as events using the underlying broker of our choice, right? You could, again, switch out the broker. You could maybe use something else. That's absolutely fine. The concept and the architecture principles is the most relevant one. to answer your question, so even Google's agents are not completely or 100% A2A compliant. They still have these unique properties that they embed within it. Not all the enterprise platforms are A2A compliant. Some because they don't want to work with A2A, or they see that if they are A2A, they will be kind of a part of a whole rather than the big piece itself. So for example, SAP, right? So they just recently announced that they will become A2A compliant in 6 months, right? And that's like a long term coming. Similarly, but answering your question is, we don't care where your agents are. We don't care if SAP and Salesforce or AWS, they don't want to work with each other. We bring them a common platform, right? And again, based upon the theory of the architecture principle that events can be used as a transport model, you can have them in any other broker or any other platform to work with. Any other questions? Yes? Last one? I'm asking him. Last one? Okay.
Is it necessary for, when you use the agent mesh, is it necessary to use something like Tailscale, or to keep everything in the same sort of a network, or is it open to the entire internet, and do you need authentication?
You can pretty much dump the whole thing in a Kubernetes, and you can deploy it in your own private VPC or a private network or your private laptop or infrastructure, whatever you have. The way that I like to work is I kind of like to separate the platform itself from the different agents. Why this is because I can take down agents independently of the whole platform, right? And even if you deploy it within your own VPC and you want your agents to talk to each other, so you would build what is called as a Docker network or a Kubernetes network, and you would have them talk to each other. But it does not mean that they would be exposed to the internet. You can have, how do you say it? Gated access or gated events that come into the broker, and then you can use those events to trigger the orchestrator itself. So that broker kind of acts like a big gating mechanism as well. Any other questions?